Welcome back, everyone. We are glad that the activity one was not a complete chaos. And so, like I said before, we have four, sorry that I didn't bring the jacket, that we have four lectures that kind of hopefully lay the foundations of what we'll be doing. It's a bit tricky because I know many of you have very different background and exposure to AI and large language models. So we try to assume as little as possible. So what the first lecture of this set of four tries to accomplish is just give a basic introduction to AI, its concepts, nothing technical, very, very simple, a little bit of where things are going, and some examples on the impact on chemistry research and to a very little extent society. So just as a summary again, I think I mentioned most of these points already. So the bootcamp's idea is not so much to really talk you, not at all, hopefully, to talk you into a particular opinion, but to kind of provide really practical starting points that if you want to use it more or explore AI methods for your research and teaching, you can have a good starting point for that. So we hope to give you some hands-on experience. This is the first time I use it. So show you some examples. We also want to explain the nomenclature, what are key terms that we'll be talking about, discuss opportunities. We will maybe once in a while predict the future, but we really want to stay away from it because who knows what the future will really bring. But some short-term trends, of course, can be seen. So what we will not talk about is, although these are very important topics, predicting the job market, things like that. I'm definitely not an expert for that, if an expert for this exists on the planet. So is there a bubble or not? I have my personal opinions. I have no idea whether they are valid or something like that. But we will not talk about it. Equally, we will not talk much about the mathematics and programming. We kind of shortcut this a little bit. This is probably not a good way of doing it long term, but for the bootcamp, that's the way we will be doing it. So I hope that I will never tell you what to think about AI. Just keep an open mind and listen to the facts and whatever you make out of it. And if I should ever try to bias you, I apologize for it. It's definitely not my intention. So one term that came up maybe a number of years ago, 4 or 5 years ago, is that these large language models are stochastic parrots, okay? So they're repeating, you train them, and then they're repeating what other people said and did with a little bit of statistical noise, okay? So a professor of philosophy at Wisconsin had this kind of course, not flattering word, stochastic parrot. And we all know that from experience that this is sometimes how they behave. On the other hand, the last month and even the last weekend have seen amazing mathematical breakthroughs, right? As a non-mathematician speaking. So you can today seemingly prove theorems and disprove theorems of some notable level, meaning publishable in good journals with large language models, right? On last weekend, OpenAI published 10 notable proofs of mathematical theorems, right? They're still being verified. There's some automatic verification, so they're probably sound, but human verification still awaited. And so there's some tension here, right? Is it just the parrot that kind of repeats words with some kind of noise in there? Or is it this mathematical genius? We don't know. So I want to give you another example. So these are two poems. One is from Lord Byron, famous poet. The other one is from ChatGPT, okay? And I want to get your input on what you think is which one. So I give you a few seconds to read them. I will not try to enunciate them. If you know one of the poems, please don't say. I know that Ashley knows because I told her. Okay. It was kind of nice in my book. All right. Show of hand. Is the first one Lord Byron? So we have a few. Is the second one Lord Byron? I think that's a slim majority, majority with many abstentions, right? I assume I saw a lot of abstentions. So probably honest abstentions, like I can't tell or I don't care. Yes? Oh, okay, good. So it's not obvious, let's say at the least. And I'm not claiming that an English professor or an expert in poetry or a fan of poetry couldn't tell the difference. But the first one is actually Lord Byron. The second one is ChatGPT. And she got it right. Oh, 2 and 2. 2 and 2. Okay. Yeah, I think it's subtle. By the way, I wanted to make one quick comment. So we are only recording the lectures. We are not recording any of the discussions or activities. But if you ask a question during the lecture, which is great, right? But be mindful that you might end up in the recording, right? We can cut you out if you, because I hadn't announced it. Your comment was though very good. Okay, so this has been studied actually. And so there were papers in 2024, and I pulled this one this morning, where it's from August 2026, that says that we are not good at doing this. We actually really can't. And again, this is not experts, right? I mean, experts, I'm very confident, can tell the difference. And not only that, we often just go the wrong way, right? So we are maybe a little overconfident whether we can tell this stuff apart. Okay, so brings me to the next point. I want to embed it, although we don't want to talk about society too much. I think it's also ridiculous not to mention it a little bit. So what are the bigger picture ideas about AI, forgetting about all the concerns and technical things for a moment? So there's this Amara's law that says that we are overestimating technology in the short run, and we are underestimating the effects in the long run. I think there's a lot of truth to it. It doesn't mean that it's always true, but there's some truth to it. I personally believe that next year will look very similar to this year for most of us, not everyone maybe. But the long-term impacts could be quite substantial. And I have this kind of not very deep table here where I look at some really revolutions in human development, the development of agriculture, the writing system, devising a writing system, printing press, right? Being able to communicate to more than a few people. The scientific revolution, right? In the Renaissance, industrial revolution, the moment when physical labor for the first time became a little bit less important than it was before because we had powerful. And then recently the internet, right? And its internet bubble. And nonetheless, the internet is still here. And now artificial intelligence, possibly, right? And when we look at this randomly a little bit here, like I said, I wouldn't put too much into this, but we see immediately some short-term impacts. Of course, agriculture changed the way people worked, right? And but then there are thousands of years later, impacts on the way we eat, right? The way our health is, how our agriculture, modern industrial agriculture works, what nutrients we get. So sometimes these consequences occur much, much later, right? So there's a very good chance that what is happening in the moment, yeah, it will disrupt several things and confuse definitely all of us, but there might be consequences felt in hundreds of years. So of course you could say, is AI perhaps not a good fit for these major categories that I showed you? Maybe it's just like this thing that will disappear or plateau, and that's completely possible. But we can look a little bit at investments into AI technology, right? And it is quite substantial. So these are capital expenditures today, AI investments, if you want so. And you see that global energy takes the winning spot with $3 trillion, trillion, million, billion, trillion. Defense, 3 trillion. And then AI at roughly 50%, 1.5 trillion. It's still an enormous, compared to my salary, a very enormous amount of money. Then everything else looks kind of small in comparison. Even space, and a lot of money goes into it, is half of it. And then pharma is again half of it, pharmaceutical industry, right? I would think they're investing big. And then things like quantum computing, this is mainly private venture capital, is even 2 orders of magnitude smaller, right? So whatever the details, we see their scale differences, right? I mean, this is not like a factor of, is it factor 1.2 or 1.3, big, big differences. So lots of money flows into AI, and we can already feel as scientists and researchers the impact of this. So this is my personal feeling about it. I think it resonates with what I hear from other people. So you see already some stress on the number of papers of the publication system and the proposal system. So the number of papers submitted, the number of proposals submitted is just really going up very quickly. And that could be, in principle, a good thing, right? We learn more, we accelerate research, but our current system is kind of under stress because we have human peer review, right? And if the number of papers suddenly, so if you publish a paper, it's sent to some other people to review before it can be published. And these are volunteers like us, and puts a lot of stress on it, right? Another weird thing is that I've talked with many editors from scientific journals, well, at least a few, and they said they have statistics from web browser readouts that most of the accesses to papers and their journal homepages are done by chatbots, if you want. So ChatGPT. So ChatGPT seemingly reads our papers more than humans do. That's super weird, right? If this trend continues, are we writing the papers for a chatbot, or are we writing it for ourselves? And how should we navigate this? External funding, and I'll show you a number, is shifting towards AI-driven research. Not necessarily bad, but there's some weird consequence that there could be the scenario where if you have a research question that you can answer by AI, and not everything can be answered by AI, it might be a favored thing, and in a weird way stir the research process away from interesting topics that are just not that AI suitable. So that's weird. AI-generated ideas, some people believe, have become cheap, right? So it's less about ideas, it's more about data and experimental capacity. That's a big change, because usually we, as academicians, value ourselves for our smartness, not how many hours we labored in the lab, and or how many megabytes of data I've generated. So large data, automation, and related to it, transparency has gained importance. And then we will all feel it. You will be teaching. Many of us are teaching. The teaching landscape is changing, right? I don't have to say much about it. People are cheating with ChatGPT on tests, and they're writing their college entrance essays with ChatGPT. It's disrupting the system. The system will adjust, I think, but it's definitely a disruption for the time being. So this is where we are going. And of course, you want to go, especially when you're young like you, not to where things were last year or this year. You want to kind of anticipate the future a little bit and go where the puck will be, right? But the problem is there's nothing more difficult to predict than the future, okay? So how can we get some kind of more concrete data points on this? And this is my random collection. I could have picked other things. I'm sure there's some evidence that would show the opposite. But a big thing for us scientists is, and PIs, $5 billion for just the Genesis project, right? That the Trump administration pumped out into research for AI-driven research. No, 5 billion, 5 million, what's the difference? But to give you a reference point, most of the people in this department rely on NSF, National Science Foundation funding, okay? And the total annual budget of the NSF is 8 to 9 billion, okay? So this is substantial, right? It's not like, oh, there's a little, encouragement to do AI. These are major, major investments. we actually got, as FSU, as a university, 4 of these things, which is pretty impressive. Then the other weird thing that is happening is that very established university researchers are moving away from universities to either universities who provide enormous funding for AI research, or more likely to these open AIs and Anthropics to do their research there. That is partly salary and money, but it's also just access to these enormous computer systems that they have. So a notable example would be this Fields medalist. On the day he got the Fields medal this year, he said, "Oh, I'm leaving Toronto. I'm going to OpenAI." Another one is the guy here that won the Nobel Prize this year, last year. And he was at UC Berkeley, well established, good place. Sure, he had money. He decided to go to China and lead an AI institute there. So this is the guy who did metal organic frameworks and stuff like that. This is not a computational chemist here. Okay, so here's another snapshot of this. And I don't know how much you know about it, but we put the references at the end of the paper, right? And then nowadays, we are kind of partly judged by how many people put your papers into their reference list. This is called a citation. And a typical chemistry paper gets, say, 10 citations. Half of them get fewer than 10 citations. So really notable papers get in the thousands, okay? So let's look at 2 AI papers. And I'm not saying that there's lots of junk AI papers, right? But let's look at the 2 of the top AI. One is this Atom Optimizer. It's a very computer sciencey thing. The paper is from 2014, and it got 250,000 citations. Okay? This is the second most cited paper ever. And the other crazy thing is it was never peer-reviewed. They put it on arXiv. It was never published in a journal. Another example is AlphaFold. This, I think, is the AlphaFold paper. It got 53,000 citations, right? So they also won the Nobel Prize. It has a big impact, and a big positive impact, I think, in biology and biochemistry. So these are kind of big numbers. And then there are other positive things, and I picked this paper somewhat randomly. It's a very recent one from July, I think. It shows that we can expect problems and we can expect positive things. Like our medical diagnostics will get better, right, with AI systems. These guys trained a transformer on just routine clinical data and claim, I have no opinion on it, in a peer-reviewed top journal, that they can predict cancer a year ahead of time from routine data. That would, if true or partially true, this would be amazing, right? I mean, no one can deny the value of this, I hope. This I also pulled from the American Medical Association. I think, not a medical scientist, but a big professional organization. And they polled 1,600 physicians in the US on how much AI they use and how they see the impact. And 1/3 of them use AI daily, another 30% at least once a week. And the opinions on AI were such that they felt that it increases work efficiency. I think a lot of it's just like writing reports and scripting and stuff like that. It increases diagnostic ability, decreases the cognitive overload. And the only things that are a little bit on the negative end, definitely patients' privacy. At least that's how physicians perceive it, and I think it's probably true. And that it can kind of mess with the patient-physician relationship, okay? But overall, we can see that physicians are using it. It's not like this toy that is being used. They're using it really to hopefully achieve better medical outcomes. And 92% of all physicians want to learn more about AI. All right, so the next slides, longer set of slides, is the 2026 Stanford AI Index report. So this is like a benchmark in the community for seeing where AI is going. It's moving very quickly, so this is probably kind of towards the beginning of year, end of the year, so the most recent things are not captured in this. And they have, it's publicly available, you can just click on it, it's a massive document, and they've collected a lot of data on where AI is going. So we want to go through it slowly, but definitely things are, they diagnosing that AI capability is not plateauing. It's accelerating and reaching more people than ever. I'm completely well aware that there are lots and lots of Americans who never touched it and have no use for it. Think internet. Some years ago. The United States hosts the most AI data centers in the moment, but China is catching up fairly quickly. AI models can win gold medals in international mathematical Olympiads. I've showed you already the proofs. But weirdly enough, you can trick them sometimes with very simple things, like asking them what the time is, right? Or at least a few months ago, you could still trick them with asking how many R's are in strawberry. Okay. So we will look a little bit at this report, and I will highlight a few things. So this one kind of strikes me. It is the AI-generated content, probably mostly text, but also video and images and stuff like that. And since, so you see, this was essentially zero, the purple curve for the longest time. But then around 2022, 23, it picked up. And that seems to plateau a little bit. But it's now at roughly 50%, 50-50. The stuff that we are creating, text, images, photos, videos, is 50-50 AI and human. So it's not a minor thing. Here is the data. Yes? Mm-hmm. Yeah, it's a good question. I think this graph could go to 100%, right? But I don't know why it's plateauing. And I think it hasn't completely plateaued, but plateaued a little bit. Yeah, no, the sum is 100%. That's my understanding. There are these two categories, absolutely. But it could be 100% AI and 0% human. So this is the data number. And I know many of you and I have some concerns about data centers. We have actually, one thing that I've learned, we have one in Tallahassee, in the middle of the city. It's a smaller, older one. It just runs internet stuff. And I was like, wow. And you can visit it. That's crazy. And so I was completely unaware that we had one. But there are, of course, also these big, massive ones that people are more concerned about. And there's no doubt that the power capacity, the energy consumption goes up, right? And the way I see the curvature, it will probably go up more and more. So energy from data centers is increasing, and that is definitely a concern. So these are three things that I feel like are important: CO2 emission, power consumption, and water consumption. And I know that some of you will disagree with me, but I think the big thing is the power consumption, with all the negative aspects that could come out of it. So the CO2 emission of a typical prompt, so what I did was maybe a little bit more sophisticated and energy intensive earlier this morning, is comparable to driving a car for 50 to 100 feet, the hyphen is missing, or running your TV for a minute, okay? And interestingly enough, okay, so it doesn't mean that it's not producing CO2, it is, right? But it is not the CO2 explosion, depending on how power is generated. And the power consumption is really a big thing. So a short GPT-4o, an older model query, was not that different from a Google search, okay? And that I could talk a lot about this. Google searches are also energy expensive. What you did before, what we all did before, was very energy expensive. And the way this is done, it's very hard to find data on it. It's not like these companies volunteer this data easily. So the Google data is actually fairly old. The AI companies, ironically, are a little bit more open about it. And so I think that the power consumption and energy hunger of these AI data centers and AI in general could be a really big problem for us unless we find clean ways to generate electricity. And I think chemists can contribute a little bit to it. And then we have water consumption. So I personally think that this is a local problem. Okay, so there are surely neighborhoods where water consumption by AI data centers or data centers in general cause stress on the community. But from I showed this to someone in computer science, and I sent him the references. So the US almond production in California takes 4,500 times more water. Okay, one almond that you eat, the little nut, is 1 gallon of water. Okay, we never really worry too much about it. Although locally, it drains all the groundwater and everything like that. At the same time, I think someone mentioned it, these guys don't want to use water or electricity, so these things kind of come down, especially what water consumption is consumed. So I was actually very doubtful for a while that data centers consume water beyond toilets and stuff like that at all, because this is how a power plant looks like in Germany. You see from the river water, the steam coming up. I've never seen a photo of a data center with the steam coming up, but you do find them online, right? So they do evaporate water during the cooling process, while some are actually closed systems, more modern ones. Okay, the data centers are big, okay, and they will only get bigger. And whatever we feel about it, I think this is going to happen. So this is a big Amazon Web Services data center that's under construction still. You see it in the back. So these are massive things. I wouldn't want to have them as my neighbor, but to be honest, I also wouldn't want to have an Amazon distribution warehouse as my neighbor. Yeah, so that is, of course, a problem if you have it in your neighborhood and local politicians didn't help you to kind of prevent this from happening, or state politicians. So these things are big, but then we are chemists, right? Our chemical plants are also not like little babies, right? We build, islands full of chemical plants, right? And so scale is a weird thing when you start to think about it. If you ever go to Louisiana, look at some of the refineries there. It's pretty insane. It's like science fiction. What I, as a scientist, find kind of exciting is that you can look at this data center and kind of see it goes down to these racks of computers, then it goes down to chips, right? And then it goes down to nanotechnology. So let's have a quick look at this. So these are the, I think, in the moment, more or less state-of-the-art Blackwell things that NVIDIA ships. And they're massive, right? They're currently water-cooled. And they're filling these data centers that we just looked at. So there's like an enormous amount of computational power there and equipment. It's crazy. And you can look at some statistics, maybe you read them. It's kind of mind-blowing. And if you go a little bit further down, you see where we scientists made a concrete, or natural scientists, physicists and chemists made a concrete contribution. Each of these data centers consists of racks, consists of computers, consists of transistors. And you look at the transistors, we are essentially arranging them on an atomic scale, right? So each dot here is an atom. So whatever you think about data centers from an engineering point of view, it's pretty insane. You arrange atoms and then you build the city block-like thing out of it. All right. Another aspect of the Stanford Index, AI Index report, is this question: how do we evaluate AI? Every company will claim theirs has gotten better, right? And so we have these benchmark tests, and one is humanity's last exam. It's a very dramatic word for it. So the prediction here is that soon humans will not be able to construct tests anymore that are smart enough, difficult enough to evaluate how good AI is. And so what this last exam, in quotation marks, means is that they ask experts in the fields at universities, companies, to come up with the most difficult question they can come up with. And then people check the answer and check that this question was not somewhere on the internet or in the literature, okay? So, and I've absolutely, no idea how to answer questions like this in chemistry. I put up a chemistry example from the last exam. And actually, last year, AI also didn't do that great. You see the numbers, right? They're like maybe 10% for 01, but by now that's an old lab model. So, so chemists are still okay for the time being, right? Let's rejoice. But the trajectory, who knows? So this is the inability to kind of evaluate AI in the near future without AI. So there are many other interesting points in here. Just pick the last one. AI models are expanding into many professional domains, right? And like I said, I think we are not really the target in the moment, but applications like tax evaluation, mortgage processing, corporate finances, legal reasoning, and stuff like that might be some kind of the more vulnerable areas. All right, so I want to switch gears a little bit, and I think we all understand a little bit how you can maybe confuse yourself or solve research problems in chemistry with AI, but they're mainly thinking problems, right? Come up with an idea, get an answer, stuff like that. But there's another component to it that AI is entering the labs, okay? So I show this as the first example. This is from a colleague in Glasgow, in Scotland, who started a company in the US, Chemify. And the idea is essentially to do AI-enabled, fully automated syntheses. He calls it chemical programming. So rather than programming a computer, you're programming this type of equipment and it makes a synthesis for you, or the product that you want, with all its limitations, obviously. So it's kind of fun to see this stuff operate, right? And the fact that it's automated is cool. But what makes it even crazier is that AI will control it, right? It will read out the result and then say, oh, okay, this didn't work. So I have changed this, run the next one, run the next one, run the next one. Still looks kind of small scale. But this is a more recent example, well, 2023, but it was very prominently covered in Nature. This is Berkeley National Lab, California. And this is what they call the A lab. So you see a little bit, this is for solid state material synthesis. And again, the idea is you mix, bake, shake and bake, right? You do your analysis completely automated. The arm moves the samples around. The AI looks at the result, plans the next synthesis, okay? And it has a goal, what kind of material to produce. So these things get very, very fancy. And you can probably also see that a single PI lab will probably not pull this off, right? Because it's too expensive and too difficult. So these are major things. You see how it goes there into the furnace, right? Shake and bake. And there's a baking step. Well, that was a national lab. So our colleagues, these are our colleagues from industry. So the idea is to put labs in the cloud. So the idea is that we will not have labs anymore. Their idea, right? I hope it's not happening. We will not have labs anymore. You just send the order out to an automated facility, and you might not even say anything specific. It will just plan the whole thing for you and deliver the product that you wanted. So these are giant facilities also already kind of popping up. This one is in Boston, Ginkgo Bioworks. And I think partly driven by money, often this stuff is biologically relevant. But it's an interesting thing to keep in mind that labs might also change a lot, right? Because once these things go up in scale, okay. One thing that I find fascinating is these are these fully automated labs, but there's also this whole humanoid robot aspect to it. And so I just want to show you one of the things, robotic hands. I'm personally kind of fascinated. I would love to have a humanoid robot in the lab and see whether I can teach it to pipette, right? Or weigh with a traditional balance. Maybe that's not how labs will develop, but who knows? So just to show you how good these hands have become. So this one is fastening some screws. It's kind of entertaining, also a little scary. Not a whole robot, just a hand and a bit of an arm, pipetting. So a lot of pipetting tests. They're automated pipetters, by the way, right? But the idea here would be it's a more versatile platform, right? 1 minute it pipettes, the other one it goes to the cabinet, gets some chemicals, right? Stuff like that. A little interested in this, pipetting is actually very error-prone human business, right? Especially if you're not good at it, right? So error rates in volume can be like up to 8%. It's kind of crazy that the whole literature has this kind of volume and concentration in accuracy. So how do you train these robotic systems? The left one is a little dystopian, but it's happening. People get these cameras on their head and generate video training data, okay? And he still looks happy. I think I would be quite grumpy if I had to do this, to say the least. And so you generate the video training data, AI is trained on the video data, and then maybe the humanoid robot or system can kind of reproduce it. This is starting to be used in the industry for package sortings and the simplest of all kinds of things. I think actually that this is a little bit on the way down. because the video data is kind of hard to get. And so what most modern systems are doing, they're training the robots in a virtual world. Okay, so you create the virtual lab or the virtual staircases, and you spawn out thousands of these virtual robots. You know exactly what their specifications are in the software, and they're training in the virtual world. Okay, so you still probably have to do some post-training and all kinds of things in real-world applications, but a lot of the training of these robots is happened virtually. Looks also crazy. So this scares me too, to be honest. But they're also, my parents are old, right? My dad is in a retirement home, in a wheelchair, can't get around. They have good service there, but man, I mean, it's difficult. So there are companies, especially in China, but probably everywhere, that are trying. I don't really think that works yet, but you know, as a prototype or vision, these systems that can help people stay longer at home and be safer and live a bit better life. So the thing is a combination of wheelchair and personal butler / security guard, right? If you collapse or something like that. I saw many of these videos while preparing. Sometimes just having a robot there playing a board game with old people can be kind of a nice thing if they have otherwise nothing, right? Is it ideal? No, but that's the world we are living in, I guess. Okay, so this was just some kind of big overview, and I want to introduce a little bit of nomenclature. We all heard these terms, right? So what is AI? I read out that sentence. I feel like it's important to do it at least once. AI includes any method that enables machines to perform tasks associated with intelligence. Doesn't mean they are intelligence. They're associated with intelligence. So machine learning is a subset of this, and it's essentially where systems learn patterns. And this is perhaps very important for chemists, right? We look for reactivity patterns in the features and characteristic of materials that we've made, right? Stuff like that. So they're very good at spotting this, sometimes at least, and can assist chemical research in that way. So that's machine learning and a smaller set of AI. And then within the machine, smaller subset is deep learning. So these are these systems that spot patterns with fitting millions and billions and trillions even of parameters, okay? So where I do my curve fit and I fit a parabola in there, 3 parameters, they fit 1 billion or 100 billion. And these patterns that we often wouldn't see in the data can be bad patterns, right? In the sense that they lead you down the wrong way, but often they are right. And then there's generative AI. So these are things that are producing output like text, images, videos, music, sound, stuff like that. So they generate some form of output. There are other things. The first definition is maybe not so important. Narrow AI is built for a bound task. Like I want to get this type of synthesis right. Okay, that's much more narrow than what, let's say, ChatGPT aims to do. Frontier models, we've heard about it. These are just like the best models publicly available, right? And then artificial general intelligence. This is you hear a lot of talk about it, but it's a really poorly defined term. Everyone has a different definition. Some people say it's here. Some people say it's years ahead of us. Some say it will never come. But the idea is that you have an AGI, kind of human level competence, not only in one limited field, but across the board, okay? One thing that I find fascinating and scary is self-improving AI. And this was like a demo from, or just a logo essentially from Anthropic. So to some extent, this is already happening. So you train the AI model, and then you let that AI model help or train the next generation of AI models, okay? So this leads to an acceleration, right? And in a direction and speed that we rate that we can barely, you can only speculate about. So AI systems itself improve. And then there's also this artificial superintelligence that's, I think, more like science fiction stuff, but who knows? So not only equal to human, but better as humans across the board. So these are the terms that are thrown around. And one interesting sub-aspect is this, what's called the bitter lesson. You hear it often at talks, even here in this room, people have talked about it before, chemists. And the bitter lesson was that when you start working on this, you think, hey, I'm a chemist. I will make a chemistry AI. And I'm actually an expert in this type of chemistry. So I will I have all this knowledge and instinct, and I will install that into my machine learning AI system. Okay, makes perfect sense, right? And that's how I would start it. But experience, not a law, shows that those systems are usually outperformed by general systems. So the strategy is not to teach them our tricks, but the strategy is to have them teach themselves, right? And the classic example, and maybe some of you watched the video that we recommended, is this board game, the Asian board Go, right? It's a little bit more complicated. I don't even know the rules than chess. And they try to build these expert systems, and they did well, but not great. But then they had the AI play against itself, okay? 1 match, 10 matches, 1 million matches, 10 million matches, right? And learn from it. And although no one really told them strategy or anything, they discovered it and got very, very good. And then outperformed the best human players at some point. So that's the bitter lesson, that often the general approach that feels stupid is a better approach. All right, then another thing that I can't avoid, I'm a big Alan Turing fan for other reasons than this, is the Turing test. So this has been around throughout all my life, except for maybe the last years, and it seemed impossible, right? So the Turing test is very easy. It says, hey, a machine is intelligent or human-like intelligent if you communicate with it and you can't tell the difference anymore between communicating with it reliably, right, with a human or with a machine, right? So that's a Turing test, essentially a wall. There's some kind of human or mechanism behind it. You communicate, you ask, right, what did you eat for lunch, right, and stuff like that. And it tricks you. That was completely impossible 10 years, 5 years ago. But definitely in 2023, there were 1 or 2 studies that really did the experiment, and they showed that we passed that point. So these AI systems pass the Turing test, and we can't reliably tell them. This doesn't mean that there's not a world-leading expert who can tell them apart, or that they're bad systems, but the threshold has been passed. And this is a little video. The audio quality is very poor. It's from the 80s. And it's an aspect of this Turing test, a fancier version. And it goes to this question, when is the system really understanding? Now, when we talk about understanding, the first thing is we don't really have I don't have a good definition. I'm sure there are definitions, some are better than others, what understanding is, but we all think we understand understanding, I think, to some level. So let's listen to the clip.
And to their credit, a lot of people in AI insist that we are using these words in their rules. Finally, the rules that we understanding the attributes of the computer is not staying understanding the attributes of the human. Well, what I ask you to imagine is this. I like to do it in the first person and have everybody do it from their own point of view. Imagine I'm locked in a room, and I got a huge box full of Chinese symbols. I don't know any Chinese, just so many squiggle signs to me. Then they bring in another box full of Chinese symbols, and they give me a bunch of rules in English for matching these symbols. So it says, take a squiggle sign out of box number 1 and go and put it next to a squiggle sign out of box number 2. Just to jump ahead a second, that's called a computational rule of a formally specified element. Okay, now let's suppose they give me another little batch of Chinese symbols together with some more rules in English for shopping these symbols. Only this time, I give them back. The chaps who were giving me all this stuff, they wouldn't know. I give them back some Chinese symbols. So here I am in my room with my 3 bunches of Chinese symbols. I'm shuffling symbols around. Symbols are coming in, and I'm shuffling them back out. Now I imagine, unknown to me, the guy who gave me the first box called a restaurant. The second box they called a story about a restaurant. The third bunch of symbols they call questions about the story. The rules in English they call the program. The answer, the stuff that I give them back through the window, they call answers to the questions about the story. And me, they call the computer. Now, let's suppose that after a while, they get so good at writing the program, and I get so good at shuffling symbols, that my answers to the questions are indistinguishable from native Chinese speakers. So the story comes in, I don't know, it means it's a bunch of symbols. But the question follows, did the guy in the restaurant eat the egg foo young? And I get back a symbol that means, no, the guy didn't eat the egg foo young. Now, I passed the test for understanding the story, but I don't understand a little bit of Chinese. I think that is the Turing test. That's so they were worried about that. Well, Alan Turing, a great British mathematical genius, invented the test for determining whether or not we should attribute understanding to the computer, and the test was, could the computer fool an expert? So let's suppose that I can fool the experts. My answers to the question are as good as those of native Chinese speakers. Imagine they even give me a question of the form, do you understand Chinese? I give them back answers that mean in Chinese. Of course I understand Chinese. Why do you guys keep asking me these stupid questions? Can't you see I'm passing the Turing test? Now, here's the punchline. This is the point of the whole analysis. I do not understand a word of Chinese. And if I don't understand Chinese in this example, neither does the computer.
So it's an interesting thought, right? I mean, what does understanding really mean, right? This guy performed marvelous at these tasks, but there was clearly no understanding. That is a very important, the Chinese room thing, big thing in this cognitive AI science. And it has been heavily criticized, okay? But it gets you started to think a little bit about what understanding and intelligence and all of these things mean. So it brings us to large language models. We've all seen it, but these RAGs are pretty interesting. So this is essentially a form of model that first gets all kinds of information in that then inform the outcome of the answer. ChatGPT is a global leader, but it really went down, and Anthropic picked up 855, this is Claude, 855% last year, right, market share. There's Google Gemini, this is the system that FSU recommends in the moment and endorses, with some contribution. And then there are many other little ones that are in the percent range. So that's the large language universe. And there's just some metrics for the PhD students affecting me equally. No matter how it's measured, how well are these things performing on PhD level science questions? And we have been reaching now essentially with Opus 5 Max, which is not the newest model, second newest, I guess, in April, about 90%, a little bit more. Okay, so that's our competition to some extent. All right, so that's one. There are more. This universe is changing every week. So there are live tickers on how they're doing on different categories. And the moment the leader seems to be Claude Fable 5 and GPT 5.6 Soul. Okay, so these are the two best publicly available models in the moment on those metrics. Quick example, if you've never seen it, I asked it whether an AI bootcamp is cool. It said it's cool. So we can draw chemical structures with it, right? That was very, very laughable just very recently. But now you can say, oh yeah, do this, you get smiles code, it draws the structures for you. There's something called RDKit. If you're unhappy, ask it to use RDKit. You can ask fancy quantum mechanics questions, undergraduate level, but fancy nonetheless, about harmonic oscillator. It gives you correct and nicely formatted questions. You can ask it to plot those functions and so on and so forth. I found that interesting. So there was a study, admittedly sponsored by Anthropic, but by scientists, academic scientists, who looked at how good is it in interpreting NMR spectrum. And they had ChemDraw and other expert systems as a reference point. ChemDraw is not free, right? And it performed equally well, maybe a little bit better in both directions, predicting the spectrum for a molecule and predicting the molecule from the spectrum. And this was done with unpublished data from, or very recently pre-printed data from the internet. There can always be a little bit of leakage. We do these table of contents graphics, right? So an outreach. Sometimes if you want to have a molecule, just a cool looking picture, I'm not saying this is particularly cool, you just one prompt away from it and a little bit of poking around to get something. I like this. I can use my handwritten text from equations and say, oh, just turn it into nice equations, and I want to download it as a PDF or Word file, LaTeX. So that works really well. I'm always thinking of running all my old notes through it and have a nicely looking book. And my handwriting wasn't great, but not bad either. Translation is awesome. So you guys can read this. I mean, first of all, it's German, right? But any idea what those two letters are? FF. hey, Sauerstoff, oxygen. So you can look up old literature, take a crappy picture of it, right? Run it through ChatGPT and say, transcribe the German text. And here's the German and the English translation and some kind of historical notes. Pretty crazy. Some people will hate this, but I like it. So I had this story about using AI, generative AI, Suno, to generate songs about physical chemistry. So here's one about the molar volume, okay? So I generated the text with a large language model, copied it over to Suno, and generated a song about molar volume.
Volume per mole, that is the rule. V over N defines the scale. Change the amount, the total shifts, but the ratio never fails. It's intensive, it stays the same. Leave the extensive variables behind. Double N and double V, but V sub M is unchanged. V sub M, molar volume, at fixed T and pressure we find. Same conditions, same value, independent of amount. SATP sets the point 298 Kelvin, 1 bar, 24.8.
I spare you the rest. I know some people hate it. I will not even, I don't dare to ask. My ego could not take it. But keep in mind that a lot of things that we are doing is also outreach. If we get money, we have to ask for it. We don't get it for free. Legislators and government expect that we are kind of reaching out to the general public and explain a little bit why we are doing what and to what end. And I think generative AI can be kind of a useful thing. And so I picked this one. I'm not saying it's the best, because it contains a little bit of advice for the new graduate students.
You spend half your life trying to arrive, then one day you realize the road was the interesting bit. Destinations are overrated. Most of them don't even have snacks. So keep moving, keep laughing, and if you get lost, do it beautifully. Of course, getting lost is only embarrassing if you were pretending you knew where you were going. So enjoy the scenery when the map gives up, because shit gets weird on the open road.
So here's the character's comment. Enjoy the ride. Okay. So that brings us to the second activity, and I hand it over to Gwen.